So just a reminder, next week Friday is our first test. It's going to be on Blackboard, so all online. I will talk about exactly what you can and can't have for the test, like next week. And I will be putting something up on Blackboard about how to access the test, what you need to download onto your browser to use it, all that good stuff. Just be aware you will need a webcam of some sort to be able to take the test, and a microphone as well, just so I can watch you, see that it's you actually taking the test, and make sure you're not getting any outside help. But that's next week. And all the material on the test for test 1 will be in our test 1 folder. Now, I want to pick up right where we left off on Wednesday, where we were figuring out the molecular mass of elements. So we did A, B, and C. Now we're going to move on to D, E, and F. So I will do D for us. And what we're doing here is that we're doing conversions like we've done already in this class. But now we need to figure out the molar mass of our elements to be able to do our conversions. Just a reminder, in chemistry, the 3 main units we use when it comes to molecules is we're either going to talk about atoms, or we're going to talk about weight in grams, or we're going to talk about moles. Right? And actually, I kind of wrote that backwards. So it should be atoms to moles to grams. My mistake. And the way we convert between these atoms to moles is Avogadro's number, where 1 mole is 6.022 times 10 to the 23 atoms. And the way we convert from moles to grams is molecular weight, which has units of grams per mole. And that's what we're working on with A, B, and C. Can we use the periodic table to find molecular weight? D, E, and F takes that one step further, doing our conversions with molecular weight. So I'll do D for us, so you can see how this goes. And then I'll let you do E and F. So D, what is the mass of 72.1 millimoles of SO2? And I actually got the molecular weight for you. So we're going from moles to grams here. So we need to use molecular weight. That's our conversion factor. So like I do all conversions, I'm going to start with the number I'm given. I have 72.1 millimoles. So hopefully you know what the prefix milli means. If you still don't know that, please do review our previous slides, our previous lectures, because come test 1, I'm definitely going to test you on that. So if you don't know, I'm just telling you right now, you're going to get that wrong and it will affect your grade. So make sure you know the prefixes we went over. So for milli, there's 1,000 millimoles in 1 mole. Millimole on the top, millimole on the bottom, they cancel out. Right now I'm in units of moles, but I want mass, and mass is going to be in grams. So that's where my molecular weight comes in. Remember, when we have a slash like this, what this actually means is that I have 60.47 grams for every 1 mole, right? So when doing this, mole goes on the bottom, gram goes at the top, because I want moles to cancel out and have a unit of grams. My fraction says, well, I have a number 1 on the bottom and a 60.47 at the top. So now I can do my calculation. Take everything at the top, multiply it together, divided by everything on the bottom. Assuming I did everything right, I got this is 4.36 grams of SO2. And sig fig should be 3 because this has 3 sig figs. This has 4 sig figs. So I should take the number that has the least number of sig figs for my answer. All right, so there's D for you. So I'm going to give you a little bit of time, see if you can work through E and F now. If you have questions, please don't hesitate to ask. But I'll give everybody a few minutes to see if you can figure out E and F, and I'll be back in a little bit. So, yeah, let's do it. And if you have questions, please put them in chat. All right, so we do have a question of not knowing where to start for E. So let's logic this out just looking at our units here. So I want to know how many molecules are in kilograms of HCl. Well, let's look at the bottom here. So I'm gonna get a different shade for my pen. Maroon, sure. So I'm starting with a weight. It's in kilograms, but kilograms, you can convert the grams. And I want to go to number of molecules or number of atoms. Same thing. So following this pathway, I'm going to have to go from grams to moles to atoms. Well, going from grams to moles is molecular weight, right? So I do that conversion. Going from moles to atoms is Avogadro's number given here. So I have to do that conversion. And once I have that figured out, I should have number of elements. So for E, what I'll do here is I'll show you where the units are going to go. See if you can figure out which number goes where. All right, so E, I start in kilograms. To go to moles, because my molecular weight's in grams, I need to convert from kilograms to grams. Once I'm in grams, because of my molecular weight, I can go to moles, because that's what the molecular weight is. Once I'm in moles, I can go to atoms or molecules, because that is what Avogadro's number is. So my answer will be molecules here. So see if you can follow that logic and put in the correct number. So I'll give everybody a minute or two to do that. And if you have that, feel free to go on to F, which is the opposite. I give you atoms, and I want you to tell me mass in grams. All right, so hopefully you had time to figure out what goes where for E. So let me move my thing so I can actually write. So I start with 55.93 kilograms of HCl. Well, there's 1 kilogram in 1,000 grams, and there's 36.46 grams for 1 mole. And 1 mole is 6.022 times 10 to the 23 molecules or atoms. So doing all that, multiplying everything at the top divided by everything at the bottom, you should get a very big answer. I think if I can read my own handwriting here, I should have got 9.238 times 10 to the 26 atoms. I'll just double check that. It's always good to double check yourself. 93 times 1,000 times 6.022 times 10 raised to 3 divided by 64.46. 9.23, yep, 8 times 10 to the 26. That is correct. So any questions with how I did E or the logic behind it? If not, I'll give people a couple more minutes to do the opposite process in F. I give you atoms, give me how much that weighs in grams then. All right, so we're going to move on to F now. So let me just, I'm going to clear all this nonsense. So I have space for F. So F, I'm going from atoms to grams. Again, let's just do it without units. So if I'm in atoms and I want to get the grams, I have to go to moles first. Because the only way to convert, this is the only conversions we can really do. Atoms to moles to grams, or grams to moles to atoms. There's no way to directly go to atoms to grams without going to moles first. So my units are, I start in atoms, and using Avogadro's number, I can go from atoms to moles. And then because of molecular weight, so that's Avo number, the molecular weight, I can go from moles to grams. So I start with a big number, 5.24 times 10 to the 24. Avogadro's number says there's 6.022 times 10 to the 23 atoms for 1 mole. And my molecular weight says there's 1 mole for 84.01 grams. Now, here's a thing that people will probably mess up with the first time you do it, and that's using your calculator to do this. So if you're one of the people who in your calculator, you're going to put it in like this. You're going to type 5.24 times 10 to the power 24 times 84.01 divided by 6.022 times 10 to the 23. If you don't do any parentheses, you're going to get that calculation wrong, because what your calculator is going to do is that order of operations, it's going to do everything in the parentheses first and then multiply that whole answer by by times 10 to the 23. So you will get a massive number of grams. While what you need to do, there we go. The way I would handle this, if you'd like to put everything in the calculator at once, I would put a parenthesis after the first multiplication divided by parenthesis, then your second multiplication. If you do that, your calculator, that's the right order of operations for your calculator. And when I do this, I got 731 grams, but I will double check that. So let's do this again on the fly. 5.24 times 10 to the 24 multiplied by 84.01 divided by 6.022. 731 grams. All right, so any questions about anything presented so far? All right, then we will move on to our next topic. And next thing we're going to talk about is mass percent. Mass percent is if I'm looking at a compound, and I'm looking at a specific element in that compound, what is the percentage of weight of that compound due to that element? So that would be like the more mathematical definition. I think it's easier if you just see an example. So I want to know what percent of the weight of water is due to hydrogen. And to figure that out, I use this equation. So in my example, the mass percent of element hydrogen is the mass of hydrogen in 1 mole of that compound divided by 1 mole of water. All right. So for H2O, I have 2 hydrogens, and looking at up the periodic table, the mass of 1 mole of hydrogens is 1.01 or 1.008, depending on what periodic table you're looking at. And I have 2 hydrogens, so I need to multiply this number by 2. Divided by the total weight of 1 mole of hydrogen, or sorry, 1 mole of water. And so if hydrogen is 1.01 and oxygen is 16 grams per mole, that's why the total weight there is 18.02. I'm just adding 1 oxygen plus 2 hydrogens. Divide those two numbers to make it a percentage. You multiply it by 100%. And the weight of water due to hydrogen is 11.2%. So that is mass percent. Right. Is there any questions about the example shown here or what mass percent means? All right. So it's one thing to hear me say that. It's another thing to see it in action. So I'll do A as another example, then I'll let you try to do B. So we're going back to our namings for A. What is the mass percent of magnesium in magnesium chloride? All right, so to do this problem, you actually have to know what magnesium chloride is, right? So magnesium is element 12, and it has a 2+ charge because it's in column 2. Chlorine is element 17. It's a halogen, so it has a -1 charge. So I can just cross multiply my charges to know how many atoms are in the element. So for every 1 magnesium, I have 2 chlorines. Yeah, so just go back and review our naming scheme for earlier in the week, and to refresh yourself how to do that. All right. So the mass percent of magnesium. So magnesium, looking at my periodic table, has a weight of 24.305 grams per mole. So that is a 4, not a 9. Chlorine, looking at the periodic table, has a weight of 35.453 grams per mole. So the mass percent of chlorine is the weight of chlorine in that compound. So I have 1 chlorine multiplied by one magnesium multiplied by the weight of magnesium divided by the total mass of magnesium chloride. So I have 1 magnesium. I don't know why I'm writing M. 1 magnesium plus the weight of 2 chlorines. So 2 times, not Cl, 35.453. And I take this whole fraction multiplied by 100% to get a percentage. And so when doing that, I find that the weight of magnesium in magnesium chloride is 25.528%. So a quarter of the weight of this compound is due to magnesium. So now that you see A, see if you can go for B and tell me what is the mass percentage of carbon in C2H5Cl. So if you have questions, let me know. Otherwise, try it out, see if you get it. All right, so let's go through B then. So the first thing I'm going to do is just calculate the weight of C2H5Cl. So I have 2 carbons, 5 hydrogens, 1 Cl. So the math for that is 2 times the weight of carbon, which is 12.011, plus 5 times the weight of hydrogen, 1.008, plus 1 times the weight of chlorine, 35.453. Add that all up together, and the weight of C2H5Cl is 64.515 grams per mole. Now I want to know what the weight of carbon is, or the mass percentage of carbon. So I take the amount of carbon in that compound, 2 times its weight, 12.011, divided by the entire weight of my compound, which we just calculated, 64.515. Multiply that by 100%, and you get the mass of carbon in this compound, the mass percentage rather, is 37.235%. All right, so now that you've had a chance to actually work with one of these questions, anything that's still confusing or anything you still have a question on, not sure, anything at all? All right. So the last question of this PowerPoint is a challenge question for you. So the American Dental Association, they say that an adult female should consume 3 milligrams of fluorine per day so that your teeth don't rot away. Now, let's say that all the fluoride you get is from sodium fluoride. Therefore, how much sodium fluoride must you consume to get 3 milligrams of fluorine? So this one is a little bit hard. This one will really stretch your brain, but take a stab at it. See if you can at least get it started. See if you can actually figure out, what's it saying, and logically what are the steps I need to get this answer. So I'm gonna let people struggle with this for a couple minutes, but take everything we've learned today and see if we can apply it to a real world problem. If you have questions or anything at all, again, as always, feel free to just send me a message. All right. This one is tough. Definitely higher level than the problem we just did previously because it's a word problem. So you have to actually pick out the pieces that are relevant to us. So let me go through my thought process of this. So, and I'm just going to rewrite stuff that I know is important. So I need 3 milligrams of fluorine. So I need to eat that much. But the only fluorine I can get is from sodium fluoride. Again, this is using our skill of can we look at a name and figure out the molecular formula? So just to do that again, sodium is in the first column, so that's a +1 charge. Fluorine is a halogen, a 7A or 17, so that's a -1 charge. So together they go one. It's a 1-to-1 ratio. That's why the molecule is sodium fluoride. So the question I have is, what percentage of sodium fluoride is made of fluorine? Or like another way to put that in a more not so scientific mathematical term is, if I eat 1 gram of sodium fluoride, how many grams of fluorine did I just eat? That's what mass percentage is. That's what mass percentage tells you. So the first thing I need to do is figure out the mass percentage of fluorine and sodium fluoride, which is what we've been doing. So the weight of sodium fluoride, sodium is 22.990, plus the weight of fluorine is 18.998. In total, the weight of sodium fluoride is 41.988 grams per mole, right? Now, what is mass percent of fluorine in sodium fluoride? So the weight of fluorine is 18.998 divided by total weight, 41.998. That is 0.45246 or 45.246%. So this says, this mass percent, what this says is, if I eat 100 grams of sodium fluoride, that means I just ate 45.246 grams of fluorine. That is what mass percentage is. So let's go back to the actual question. I want to know what percentage, or sorry, not percentage, what amount of sodium fluoride, so I'm going to say X. What amount of sodium fluoride do I need to eat to get 3 milligrams of fluorine? Knowing that sodium fluoride is made out of 45.246% of fluorine. So something to realize here, when you use percentages in math, you have to use it as the decimal form. You can't use 45.246% in a math problem. To show you the logic of that, if I wanted to figure out this answer and I use this, I would say, okay, for every 100 grams, 45% of that is made from fluorine, right? And you get 100 times 45, which is like 4,500. So what you would be saying is that 4,500, sorry, for every 100 grams of sodium fluoride, there's 4,500 grams of fluorine, which doesn't make sense. So whenever you are using percentages in math, you always have to use the decimal form, where 100% equals 1. So all your percentages should be less than 1 when using in a mathematical equation. Now I just solve for X. So I can do 3. So the amount of sodium fluoride I need to eat is 3 milligrams. That's my target fluorine divided by my mass percentage of fluorine in sodium fluoride. And that should be 6.63 milligrams of sodium fluoride. So if you consume 6.63 milligrams of sodium fluoride, you have therefore consumed 3 milligrams of fluorine. So that's our challenge question for the day, using mass percentages. Right. So looking at that, is there questions? Why didn't you have to convert grams to milligrams? So if you're talking about when I got mass percentage here, that's because everything's already is in grams, is in the same unit here, grams per mole divided by grams per mole. And a percentage doesn't have units. So that's fine. So we don't need to convert anything here. If you're talking about over on the right, that's just an example. I mean, if you're doing your mass percentage right here and you convert everything to milligrams first, you get the same answer. So you don't need to, as long as the top and the bottom are the same unit. Everywhere, like, so the only 2 actual math problems you have to do are mass percentage and then figuring out milligrams of F. And since this is a percentage, that doesn't have units. Does that answer your question? Okay. Any other questions about this type of problem? All right. So that is all we have for this PowerPoint. So I'm going to pop up the next PowerPoint. Let me get it. All right. So this PowerPoint is the last one for test 1. We won't finish it today. So this is last material, test 1. We won't finish it today. We will finish it on Monday. And then we'll go into Monday's PowerPoint and finish that on Wednesday. And then it won't take all the time to finish it on Wednesday. So probably on Wednesday, we'll have like 10 to 20 minutes to do any test 1 review. So I'll announce that again on Monday. But just be aware, anything on the Feb 12th PowerPoint is fair game for test 1, which is next week, Friday. And we're going to go back to formulas now. And we already talked about our different formulas in a previous PowerPoint. What we're going to focus on now for this upcoming problem is molecular formulas and empirical formulas. And remember, the only difference between these two is that the molecular formula numbers every single atom in the molecule, while the empirical formula is just a ratio. The empirical formula says for every 2 carbons, I have 5 hydrogens. So that's the ratio. It doesn't actually tell you how many carbons are in your compound. That's molecular formula. So that's actual numbers. In my horrible handwriting, actual numbers. So that's the difference between the two. And what we're going to figure out is getting empirical formula. So one way to determine what element you're working with is experimentally. You can do something like mass spectrometry, where you just measure, okay, I have an element. What's my weight of carbon? what's my weight of hydrogen, what's my weight of oxygen. So you get those weights, and then you can do some math to figure out the empirical formula of your molecule. So let's say that we did this and we found out, okay, we have element X, and we have a compound. We have an unknown compound. Element X makes up 20% of that compound. Element Y makes up 80% of that compound. And I want to find the empirical formula. So the first thing we want to do is convert our percentages into grams. So 20% would be 20 grams. 80% would be 80 grams. Then you convert your grams into moles using molecular mass. So there are no X and Y. So you can't really do that in this stupid example I just made. So if it was carbon and oxygen instead, you take your 20 grams of carbon, convert that into moles of carbon using the molecular mass. For oxygen, you would do the same. You take your 80 grams of oxygen, convert that into moles using molecular mass. Then, get my box out of the way so I can continue to write. Then you write the formula using your moles as subscripts. So you'd say carbon, how many moles I just calculated in the previous step. Oxygen, how many moles I just calculated in the previous step. And whatever your smallest number is, you divide both of these numbers by the smallest number. Then, after you do that, if your numbers aren't whole numbers, if you still have decimals, you just multiply all the subscripts by a small number. So you multiply all by 2, multiply all by 3, multiply all by 4, multiply all by 5. It's trial and error until all your numbers are whole numbers. So that is the steps for doing this. Let's actually put it into practice and it'll probably make more sense. Okay, so if I have a compound that's 40% carbon, 53.29% oxygen, and 6.71% hydrogen, what's the empirical formula? Right, and I actually have the steps here. So we can do this together because we're about out of time. Step 1, take all your percentages, convert those into grams. So instead of 40% carbon, I can say I have 40 grams of carbon. I have 53.29 grams of oxygen and 6.71 grams of hydrogen. So that part's easy. Step 1 done. Step 2, convert these into moles using molecular mass. And let me get my answer sheet up here so I don't have to convert these all on the fly. So for carbon, I have 40 grams of carbon. The molecular mass of carbon is 12.011 grams for 1 mole. So the number of moles of carbon I have are 3.33 moles. For oxygen, do the same thing. I have 53.29 grams of oxygen. For every 16 grams, it's 1 mole. That comes out to 3.331 moles of oxygen. For hydrogen, I have 6.71 grams. Molecular weight, 1.008 grams for 1 mole. do that math. And I find out I have 6.66 moles of hydrogen. So that's step 2. Take your grams, convert them into moles using the molecular mass like we did Wednesday and today. Step 3. Now that I have these moles, rewrite my formula using these moles as subscripts. C, 3.330. O, 3.331. Hydrogen, 6.66. So that's all that means. Rewrite it. Step 4, divide all by our smallest number. Our smallest number is 3.330. So I'm going to divide all these subscripts by that number. You get C1O1. I know this isn't exactly 1. So when you find this and you get something that's like 1.99, 1.98, 2.01, 2.02, feel free to round if it's extremely close. So that's C1O1H2. 5. If your subscripts are not whole number, multiply them by a whole number. They are whole numbers. I have 112. So the empirical formula for this is COH2. So as long as you follow those steps, finding the empirical formula from percentages hopefully isn't all that complicated. All right, so any questions about what I did here? I know I went through that a little bit fast, but any questions that people might have looking at this now? All right, so just one quick announcement. No homework for today. Yay. So the reason is the homework from Wednesday already contains problems of what we went over today. And you have the test on next week, Friday. And so most of you will probably forget to do homework. So no new homework for today. So next week, Friday, all you have to worry about is the test, not to do a homework assignment. If you have questions about anything, please don't hesitate to email me. Otherwise, hope you have a good weekend. It's going to be nice and cold, so perfect time to stay inside and just study. Otherwise, hopefully I will see people on Monday. Have a good one, everyone.